Solve the following system algebraically and graphically. And we have a system of two equations with two variables, 3x plus y equals 9, and 2x minus 3y equals negative 5. So anytime you're asked to solve a system graphically, I'm going to encourage you to start by solving the system algebraically, especially when we can't use calculators. It's going to make sketching the graph much easier if we already know the solution point. So we'll start here by solving algebraically. And we have two choices when we're solving algebraically. We can use the method of substitution or elimination. So I encourage you to pick your favorite. Here I'm going to use elimination. So with using elimination here, the reason I'm picking elimination is I'm looking at my y variables and I see that the first equation has a positive y and the second equation has a negative y. So if we multiply equation 1 by 3 and then add that to equation 2, we'll be able to eliminate the y variables. So just keep in mind here that when you're multiplying the equation 1 by 3, we have to be sure to distribute that 3 through to each piece of our equation. So this means that equation 1 will become 9x plus 3y is equal to 27. And we want to now add this to equation 2, which is still 2x minus 3y is equal to negative 5. And so 3y minus 3y we know combines to 0. 9x plus 2x gives us 11x is equal to 27 minus 5 is 22. And then if we divide here both sides by 11, we see that x is going to be 2. So now that we have the x coordinate, we can go ahead and substitute x equals 2 into either equation to find y. So again, both equations work here, but I encourage you to pick the smaller one. So I'm going to plug x equals 2 into equation 1 here. So we're going to have 3 multiplied by 2 plus y is equal to 9, which leaves us with 6 plus y equals 9. And if we subtract 6 from both sides, we see that y is going to be equal to 3. So therefore, our solution point or intersection point of these two lines is the ordered pair xy, where we found x is equal to 2 and y is 3. So this is going to be an important feature of our graph. So now to continue solving here, we want to first convert both lines to their slope-intercept form. So we're solving graphically now. So again, equation 1, which was given to us as 3x plus y is equal to 9. And if we subtract 3x from both sides here, we're able to attain the slope-intercept form. So this becomes y, or is equivalent to y is equal to minus 3x plus 9. And the reason that we're doing this, the reason we're converting to our slope-intercept form, is because it gives us the y-intercept. So we know that the y-intercept is where this line is crossing the y-axis. So it's going to be the ordered pair 0, 9. So we now have the solution point, which sits on this line, and the y-intercept, which also sits on the line. And all you need to sketch a graph of a line is 2 points. And we'll do the same thing now with equation 2, which was given to us as 2x minus 3y is equal to negative 5. and we want to convert this to our slope-intercept form. So I'm going to switch the positions of the minus 3y and minus 5. This is equivalent to 2x plus 5 is equal to 3y. And we do that so everything's positive. So I have 3y is equal to 2x plus 5. And now we can go ahead and divide both sides of our equation by 3 to isolate y, which leaves us with the equation y is equal to 2/3 x plus 5/3. And so we can again see that our y-intercept here is 0, 5/3. So noticing that our y-intercept for equation 2 is a fraction, let's convert this to a mixed number here. We know 3 goes into 5 one time with 2 left over. So 5/3 is equivalent to 1 2/3, which is approximately 2. And while we sketch our graph, we're going to want to use the exact y-intercept we found here. It's always nice to know where it's going to be approximately on the graph, especially with fractions. So we're ready to sketch our graph. We have our y-axis and our x-axis. And again, we want to keep in mind these slope-intercept forms that we found. So we have equation 1 with a y-intercept at 0, 9, and equation 2 with a y-intercept at 5/3 or 1 2/3. So I want to make sure that my y-axis scale is large enough to incorporate 9. So I'll just do 1, 2, 3, 4, 5, 6, 7, 8, 9. So obviously my tick marks are not of equal size here, so it can be useful to incorporate graphing paper if you have it. And then for the x values, we'll just do 1, 2, 3, 4. All right, so let's start here by plotting the intersection of our two curves, which is occurring at the ordered pair 2, 3. So we know this is the intersection of our two lines, so it exists on both. So starting with equation 1 here, we note that equation 1 has a y-intercept at 0, 9. There is our y-intercept, and then connecting these 2 points here, we have the graph of equation 1, which we always want to label. So our equation 1 here is y is equal to minus 3x plus 9. And now we want to do the same thing with equation 2, which has the y-intercept at 5/3 or 1 2/3. So we know 1, so we'll say right about here. Again, graphing paper will make this a little bit easier, but we'll label our point for accuracy. So we have the y-intercept at 0, 5/3, and then connecting the y-intercept with our intersection point or solution point here, we have a graph of equation 2, which is y is equal to 2/3 x plus 5/3. And so this is solving our system graphically.